Well, what's up, guys? Hope you're doing well. We just left the sunny Bay Area to come up to the snow, and yeah, enjoy the sunshine.
Bobby Yamamoto.
Alright, so now we're doing section 11.4, which is the volume and surface area of a sphere. Now remember that the homework for this section is due by Friday night at midnight, the Friday before we go on spring break, so you won't have anything to do over spring break, but you have to get this homework assignment done by midnight on Friday night. Just a reminder. Okay, so let's get into it. So what is a sphere? A sphere is the locus of points, or the set, just think the set in a sense. Think the set of points. So the set of points in a space are a fixed distance from a given point called the center of a sphere. So right here in my diagram, that's my center of the sphere. And just think the dead center of a basketball or a baseball, right in the middle. A radius of a sphere connects the center of the sphere to any point on the sphere. Now, the interesting thing about the radius is that unlike a circle where we're stuck in two dimensions, and remember the radius, I can move my radius wherever I want on my circle, and the radius is going to be the same because I can move it around and connects all the sides. So expand that to the third dimension, and my radius, I can move it anywhere I want. Doesn't matter where I move it. I can move my radius at any point within think basketball, and if it starts at the center, connects to the side or the surface of the sphere, I can move that radius wherever I want. Now, so the radius connects the center of the sphere to any point on the sphere. Now a hemisphere is half a sphere. So a hemisphere, you just take a sphere and split it in half. We still have a radius, we still have the center of the sphere, but it just splits the sphere in half. Again, just think cutting a baseball or a basketball in half. Now, a great circle divides a sphere into two hemispheres. So if you were to directly cut right in half your sphere, that circle that we get, the circle right here, that is what we call the great circle. Now obviously we can calculate the circumference of that great circle, we can calculate the area of that great circle because the great circle is a circle, it's two-dimensional. But remember, it's just wherever you cut it. So I could also cut it like this if I wanted to. I could cut it like that. So you're not limited to one way of cutting it. You can cut it however you want, but it has to go through the center. That's the key thing, is that the great circle goes through the center, creating two hemispheres. Alright, so let's look at the different formulas that we can use to calculate the, again, lateral area, surface area, and the volume of your sphere and hemisphere. So to start, let's go ahead and look at our sphere. So right here, that circle is the great circle. So that guy right there. We also have our radius. And remember, we can calculate the circumference of the great sphere, which is 2 pi r. And we can also calculate the area of the great circle, which is just pi times radius squared. So what's my lateral area? Remember, the lateral area is the area of the surface going around the shape, excluding the bases. Now, do I have any bases here? No. So what's interesting about this is that the lateral area is actually equal to the surface area with your sphere, because the surface area, all of the surface on your sphere, is the same thing as the lateral area, because there's really no, you can think about no lateral area because there's no bases to split it off. So the lateral area is equal to the surface area, let's go and just look at the surface area formula. The surface area formula is going to be equal to 4 pi r squared. So you take 4 times the area of the base, which is the area of your great circle. So we take the area of the great circle and multiply it by 4. That will give you the total surface area of your sphere. Now let's go and look at the volume. Now your volume is going to be equal to 4/3 pi radius cubed. Now pay attention to this cubed here. It's easy. A lot of people, the most common mistake is that they square it and not cube it. So make sure you cube that. 4/3 pi radius cubed. And I might put a video in Google Classroom explaining where all these formulas come from. Kind of interesting. I'll try and find maybe like a Khan Academy video or something. But yeah, that's what we're going to be doing. Now let's go and look at the hemisphere. We still have our radius. We still have the great circle right there. So we can still calculate the area and circumference. 2 pi r. Area of the base, which is the great circle, is pi times radius squared. That doesn't change, but notice that everything now is just cut in half, really. So if I want to find the lateral area, notice I do have a lateral area here, because I have technically a base on top. So to calculate this lateral area, what we're going to do is, well, if we think about it, this lateral area, well, it's going to be half the surface area of my original sphere here, because I'm just cutting it in half. So if my surface area formula is 4 pi radius squared, if I cut that in half, my lateral area for the hemisphere, the lateral area for my hemisphere, that's going to be equal to 2 pi radius squared. You could also think of it as 2 times the area of the great circle, which we can say is like the base. Well, let's go ahead and calculate the surface area of my hemisphere. Well, the surface area is going to be equal to the lateral area plus the area of this base here, the area of that top of the, or bottom of the hemisphere, depending how you orient it. So my lateral area is right there. Well, what's the area of this great circle, the base? Well, that's just going to be 2 pi radius squared plus the area of the base is just pi radius squared. So when I add those together, my surface area for a hemisphere is going to be equal to 3 pi radius squared. And there's my formula. So now let's go ahead and calculate the volume of a hemisphere, where, remember, the hemisphere is just half of your sphere, so if I take this guy here, I'm just cutting it in half. So if I do 4/3 divided by 2, right, 4/3 divided by 2 or times 1/2, that's going to give you 2/3 pi radius cubed. And that's your volume formula for half of your sphere, which is the volume formula for your hemisphere. Let's do a few examples. Here we have a sphere, and quick note, I think your guys' notes, you have a line going through here. Make sure you mark that off, because that 6 inches refers to the radius of your great circle, the radius of your sphere. So the lateral area, we're not going to worry about that because it's equal to the surface area. So to calculate the surface area, it's going to be equal to 4 pi radius squared. That gives me 4 times pi times 6 squared. And that gives me well, 6 squared is 36. So 36 times 4 is 144 pi inches. Inches. Let me move this back a little bit. Second. Inches squared. And that is the surface area for this sphere. Now obviously if I said round to nearest tenth or hundredth, you'd multiply by 3.14 and then round. If it says keep pi in the solution, keep pi in the solution. Alright, let's look at the volume. Kind of cut it off here, but our volume is equal to 4/3 pi radius cubed. So that will give me 4/3 pi times 6 cubed. Well, 6 cubed is 216. I'm going to come down here and finish. So 4/3 pi times 216. Well, 216 divided by 3 times 4 gives me 288 pi inches cubed. Don't forget inches cubed for volume. And there's your volume. Now let's go and calculate the lateral area, the surface area and volume of my hemisphere here. So let's start with the lateral area. Well, that's going to be equal to 2 pi r squared. So that will give me 2 times pi times 6 squared. So it's 36 times 2 gives me 72 pi inches squared. Don't forget units. That's my lateral area. Now my surface area, that's going to be equal to, if you recall from our formula here, 3 pi radius squared. So that'll be equal to 3 pi radius squared. So 3 pi times 6 squared. My surface area is going to be equal to 36 times 3, which gives me 108 pi inches squared. So there's my surface area for my hemisphere, and again, remember, that's the total area on all the surfaces. The lateral area, that's just the area going around this bottom half right there. Well, let's go and look at the let's go and look at the volume of my hemisphere. Now remember, the volume is going to be equal to, our formula here is 2/3 pi radius cubed. So I could just plug that in and calculate it. That'd be totally fine if you did 2/3 times pi times 6 cubed and then solved. But let's think about this. I already calculated the volume for this hemisphere here. Sorry, hemisphere. I already calculated the volume for my sphere. So to calculate the volume for the hemisphere, well, the hemisphere is just half of the volume of my sphere. So all I have to do is just take this volume of the sphere, and let's just divide it in half. So the volume for the hemisphere, let's do HS for hemisphere, is going to be equal to 288 pi divided by 2, and that will give me 144 pi, don't forget pi, inches cubed. Don't forget units cubed for volume. So that will be your volume for the hemisphere, which is just half the volume of your original sphere. Now, a few other things I want to go over really quick. Let's look at composite figures. So remember, composite figures is just basically two separate figures stacked on top of each other or added together. So let's say that I was looking at this composite figure. Notice that I have a cylinder on the bottom half, and then on my top half I have a hemisphere. So the way that we do this, I'm not going to actually go through the numbers. I'm just going to explain how to do it, because going through the numbers would take a long time. So what we're actually going to do is, let's just say that, I'm just going to throw out a number. Let's say that the volume of my cylinder, let's just say that is equal to, I'm just going to make up a number, I'm just going to say 10 inches cubed. So what we do is calculate, you're going to separate these two shapes. You're going to separate it into your hemisphere on top, and we're going to add it to the volume of my cylinder on the bottom, because one's stacked on top of each other. So if the cylinder is this number here, let's just say 10 inches cubed, again just making up numbers, not going to be accurate, but I'm just making them up. And let's say that I calculated the volume of this hemisphere. I'm just going to say that this is 7 inches cubed, again just making this up. You just take each of these and calculate the volumes individually and add them together to get a total volume of, again, making these numbers up. They're not accurate, but that would give me a total of 17 inches cubed for the volume of that composite figure. Now, let's say that I had a shape like this, a figure like this. Now here I have a rectangular, right, prism, but on the top here I have this hole in a sense. So a visual that you can think for this, picture you have an ice cream container, a rectangular ice cream container, and you take an ice cream scooper and you just scoop out a scoop of ice cream. So your ice cream's all right here, and you just scoop out a scoop of ice cream. Well, what would be the remaining volume of the total ice cream in your container? That's the picture we can think of. So I started with a full container of ice cream. I scooped out the scoop right here. How much ice cream do I have left after I scoop that out? So what we do here is, again, I'm going to break this up into two different figures. I'm going to start with my original container with all the ice cream. I'm going to calculate that volume. Let's just say that that volume is, let's just say 10 again, inches cubed. And then I'm going to scoop out that scoop of ice cream. So if I scoop out that, it's going to be a hemisphere. I'm just going to say that this is, let's just say, 2 inches cubed. Well, if I'm taking it out of the container of ice cream, I'm going to have to subtract. I'm going to have to subtract away that scoop of ice cream. So I'll subtract that away, and then that will give me 10 minus 2, that'd be 8 inches cubed for the remaining volume. So that's kind of a picture of what's going on. Again, I'm making up these numbers, but I just kind of wanted to explain more of the composite figures and how you would solve each of them. If you're stacking one on top of the other, add them up. If you're taking one away, or let's say that you had a cylinder and then you had another cylinder inside of it like this, but this was so this was a hole inside of here. What you do is calculate the big cylinder. Alright, you calculate the big cylinder first and subtract away that inner cylinder, and that will give you the remaining cylinder here. So that's kind of the idea of what you're doing with composite figures. So I hope that helps. Again, the homework for this section, 11.4, is due at midnight on Friday before spring break. Make sure you guys get it done. If you have any questions, shoot me an email. Yeah, and I hope you guys have a great spring break. We'll see you when we come back.